Assalamualaikum warahmatullahi wabarakatuh. Today I will explain about the exercise one, which write a program that will store OS30 into RO. Then we will copy the content of RO into R5. Then save the data OX45785612 into memory location OX400030. Execute the program and explain the difference in the result. Okay. Like you can see, I already write the program. So for this one, I will explain how we get all this, all in this box here. Okay, for the first, on the 5 line, we use the LDR R0. We use this because we need to store the memory. So we use LDR, which is which we need to register. So we use LDR. So as the T LDR RO, so that we can get at the RO, we'll get also OX30. Okay, then the question also asks to move the data in RO to the R5. So we use the move. We use the move so we can register from register to another register. So we need use the move. So that will be our R5 will also be the R30 like you can see over here. Then LDR R1. R1 I just write this. This is for the R1 that you can see from the question. The question say save the data of X into the memory location. So if you want to save the data, so we use the LDR to save because it to the memory. So with the R1, so you can see my R1 457856112. Then then also into memory location OX4330030. So we also need to use the LDR for this one too. So R2 will get this, and we need to source data R2 into the R1. So R2330, we go to here. So that's all for the exercise one. Okay. Actually I forgot. We use this to use the base of the offset addressing mode. It store the R1 into memory location specified by the space address S40003 and emit offset of 0. That is for what we use the STR in the R1, so that in the R2 we go to the next step is the R1. Okay, next we will do the exercise 2, which write and execute a program that will add OS to FE5690, OSFE123089, and OX34589710, and save the sum in registers R7. The question also asks to record the change in CPSR. And this is the code that I already write it. So we use the LDR for this one because it was immediate data. So we use the LDR. So we store the OS R0 FE5690 in the R1. In the R2 we store OX FE123089. So for the first step in the line 5, we can see that if we execute this in the register, we can see that the R1 is also appear the same value that in the code. For the next one, in the R2, when the R2 been executed, also in the same will be appear. Next we'll do the add. Adds R7, R1 and R2. This means that R1 will be added to the R2 and will be stored in the R7. So in the conclusion that the process of sum that will get the 1F108719. Also in this for the CPR you can see the N equal to 0, Z equal to 0, C equal to 1, which means they have a carrier of value of 1. Okay, now we store the R3 OX3458970 in the R3. We use the LDR2 because it's the registers. So that you can see same value at here and here. Then we will execute the line 9, which is adds. This means we take the from before R7 from here from the line 7 to sum with the R3 and store back in the R7. We also use adds. We will have adds to do the CPR. And here you can see that the CPR is N is 0, Z is 0, C is 0, B also is 0. That is all for the question number 2. Program will store OX2936FEDA in the R8. So for this here, we will do this directly to the register, which is LDR. For the perform the following instruction that register for time. So for the first one, we will do the ASR. Here the program that I already write that I can say that there are 8 OX2396 FEDA that we can see in the LDR that read to the register. Next we can see. Okay, the first one that let's see I execute the program is 2936 FEDA, same from here. And now we this we do the after that we do the ASR execute, which will will change the value to the 0 to 936 FEDA. This which mean the for time, which mean the number of 10001 or 00 that will move and will push back into the forward. So that because of that we will get the OX to 936 FED. So the A will not be longer. Okay, next we will do the exercise 3, which is number 2 is the LSL. We use same code with OX to 936 FEDA. We just change the ASR to the LSL. So for this one we can see that RA also the 2936 FEDA. And now we execute. Now the value already changed to the 936 FED A0. Okay, for the LSL, which means we take from the end of we change all the D's to the big number and we take the end of the A, which will be a 0. So we'll move to the left 4 times, and then you just need to change the number of you need to change the number and the back of back from the rest that move, which means the right one will become the 0. So that will get the 0 because from the end you move 4 times is called the 0 in the bit, which change will also get 0, and the rest we will get the 3 6 3 FEDA. That's all for the exercise 3 and number 2. Okay, next we will do the exercise 3 number 3, which is we'll do the roll. Okay, now we jump to the program. We use the same line from we use the same 232936 FEDA. For the roll, you can see for the bit number, we will get this one. For the roll, we will take 4 number because it's 4 times, so we take 4 number. So 4 number we will take this all and we will move. We'll push back here, and the number from here will move in front, in front, in front, in front. So basically, we just shift the shift number from the backward to the front. So in the end, we'll end program. We will execute it. We will get 282936 FED. That's all for the ROM.